concept of a water budget is something that can be used not only for watersheds but also for forested areas, even going down to the scale of individual trees in a forest. When precipitation, either as snowfall or rainfall, comes from the atmosphere, it has to make it through several different layers that can return it by evaporation to the atmosphere before it ever hits the soil layer. These include the primary canopies and secondary canopies, where precipitation can be intercepted and evaporated, as well as the litter layer on the soil. Precipitation that makes it through the primary canopies and secondary canopies is often referred to as throughfall. Throughfall may land directly upon the soil or in the litter layer. From the litter layer, throughfall may be again evaporated back into the atmosphere, or it may make it to the soil layer where it may infiltrate into the soil itself. When we construct mathematical models of the water budget at the tree scale, we may consider different parts of the hydrologic cycle as buckets. Buckets into which an input is poured and out of which water flows as it transits to the next part of the physical system. The originating bucket is precipitation. As shown in the first diagram, precipitation can be intercepted by the primary canopy in a forest. In this case, the primary canopy is considered as the first bucket that has an influence on precipitation. Once water is intercepted by the primary canopy, it may be evaporated back into the atmosphere or may drip down as throughfall or stem flow to layers below the primary canopy. As throughfall or stem flow, water may be evaporated back into the atmosphere before it has a chance to flow downward to litter and unsaturated soils. When water reaches unsaturated soils, several things may happen. Water may be drawn into unsaturated soils by capillary forces as well as by gravity and infiltrate deeper into soils. However, it may also be evaporated or carried out by plant root systems, back into the atmosphere as transpiration. Generally, when we refer to evaporation or transfer of water vapor back into the atmosphere, it's a combination of several different things, including evaporative processes from surfaces that have freestanding water, as well as transpiration processes that represent plant activity and plant growth. Conceptually, from this bucket, from unsaturated soils and litter, water that is not evaporated or transpirated back into the atmosphere can sink deeper into saturated soils. Such saturated soils may be close to the land surface, and they also may be fairly deep. When water reaches saturated soils, it may become part of a flow system that recharges surface waters, particularly streams and rivers. Discharging groundwater is the primary component of surface water flows, particularly those that are seen day to day in most streams. The bucket model that you just saw is a conceptual rendering of the physical system. It's composed of several different things. First, each bucket represents a mini water balance that's focused on an individual part of the system. First, the primary canopy. Second, the secondary canopy. Finally, stem flow and the litter layer on the soil surface, and then the soil itself. Just as important as identifying the individual parts of the system that are linked is the nature of the links themselves. In order to accurately construct a model of a system such as this, we have to have measurements or estimates of key quantities. As you could see, one of the key quantities that we would have to have some estimates of would be precipitation. We would also want to know something about evaporation and transpiration. And remember, all of these things are not static in time, so that evaporation and transpiration rates that are typical of a July afternoon would be quite different than those typical of a January afternoon when plants are largely dormant. While these compartmentalized models are interesting, they present many challenges with respect to getting the information needed to accurately quantify not only the processes involved, but the behavior of specific buckets as water passes from one zone to another.